Okay guys, this is our last section of chapter 6. Okay, our goal here is to be able to graph two linear inequalities on the same graph and shade their solution area. Okay. In last chapter we actually graphed just one of these on the graph. Okay, and these have the inequality symbols instead of the equal signs. Okay, the greater than, less than, or equal to's and all that good stuff. Okay, we're going back to that, but we're putting two on the same graph. So basically what we first need to do in example A here is we're going to put these on the same graph, but I'm going to look at one at a time. So if I look at my first one, if you look at both of them though, they're both in slope-intercept form, which is y equals mx plus b. That's a good thing, okay? We always want to make sure they're in that form first. So since they are, I'm going to look at each of them individually for a second. So if I look at that top one, and I pick out a slope m and a y-intercept b, my slope's always attached to my x, okay? That's my m, which is 2 over 1, if I want to think of it as slope, as rise over run, okay? And my y-intercept b is 2, and that's always going to be tacked on the end, okay? So there's my first line, so I'm going to go ahead and graph that. So my y-intercept is 2, so I'm going to graph my dot on the y-intercept at 2, or the y-axis at 2. Then my slope says, okay, go up 2 to the right one. It's a positive slope. You can also start at the y-intercept and go down 2 to the left one, and down 2 more, and down 2 more to the left one. But then I got to think, okay, what kind of line do I need? Well, since I don't have that solid line underneath my inequality up here in the top one, this one's actually going to be connected with a dotted line. So we got to ask ourselves again that first question, what kind of line do I need? And this one's going to be a dotted line. And then I got to think, okay, what way am I going to shade? Since it's eating 2x plus 2 up here, okay, this one's going to be shaded below. So everything below my line, I'm going to shade. Okay, so that was the first line. Now I'm going to put my other line on there, so the bottom one. So if I pick up my slope and y-intercept out of here, my slope is negative 1 over 1, because I have this negative 1 out front of that x there. That's my m, or my slope. And my b is negative 3, because that's what's tacked on the end there. So if I graph my y-intercept, I need to go down 3 on the y-axis, which is about right in here. And I got a negative slope, so it's going to fall from left to right. So I need to go down 1 and to the right 1 from there. I could also start at the y-intercept and go up 1 to the left 1. Okay. So then I got to think about, okay, what kind of line do I need? Well, since I have this little bar underneath my inequality, this one's going to be a solid line when I connect them. So a solid line. And what way am I going to shade? Well, since it's eating y up here in my bottom linear inequality, I'm going to shade above on that line. So my other color, I'm shading above that line. Okay. So now I got to think, where's my solution area at? Well, that's going to be where they cross in my colors. So everything all in here. Okay, where I'm highlighting yellow, even though it looks really weird of a yellow. Okay, they're crossing in color over here. Okay, and what that means is I could pick any kind of point over in here. So say, let's say 2, 1. Oops. 2, 1. Well, what that means is I could plug that x value in for both of those inequalities and that y value, and it's going to make those both true. But say I pick a point over in here that's in one of the shades or in none of the shades, so like 1, 2, 3, 4, negative 1. If I plug that x and that y into both linear inequalities up top in my system, okay, those would not satisfy it and make them both false. Okay, so we're looking for where they cross in color. That's the area where it satisfies both of the linear inequalities in that system. Okay. Alright, if I look at B, you probably notice right off the bat that they're not looking pretty. They don't look like slope-intercept form y equals mx plus b. Okay, since they don't, it's our job to put them there first. Okay, so if I just worry about the top one a second, I want y all alone on the left-hand side. So what I'm going to do is move that 2x to the other side and subtract it over. So I'm going to leave y is greater than or equal to negative 2x plus 4. And now that's in slope-intercept form, right? So now I could just pick out my m and my b, or my slope, which is negative 2 over 1. That's in front of my x right now. And my b is 4, because that's tacked on the end. So if I go graph that, my y-intercept is 4, and I need to go down 2 to the right 1. Okay. And what kind of line do I need? Well, since I got that solid bar underneath my inequality, this one's going to be a solid line. When I connect them. Okay. And what kind of shade do I need? Well, it's eating y, so I'm going to shade above. So I'm shading above that line. So there we go. Now I got to worry about my other line, right? My other linear inequality. So if I move x to the other side, it's positive on the left-hand side, so I'm going to make it negative or subtract it to move it to the other side. So I got 2y left is greater than negative x minus 4. But I still don't have y all by itself. So what I'm going to do is divide both sides by 2. So I'm going to get y is greater than, and notice how I'm not switching my inequality around. I only do that if I divide by a negative or multiply by a negative. And that 2 wasn't a negative, so I'm not going to flip my inequality around. Then I have this right here, negative x over 2. Well, there's really a 1 right there, so this is the same thing as negative 1x, or negative 1/2 x. And then the other one, negative 4 divided by 2 is just negative 2. So there we go. I got my slope, which is negative 1/2. There's my rise over run, and my y-intercept's negative 2. It's tacked on the end. So if we go to graph that at negative 2, and my slope's negative, so it's going to fall from left to right. So I need to go down 1 to the right 2. Down 1 to the right 2 more. I could also start at my y-intercept and go up 1 to the left 2. And finish it out there. And what kind of line do I need? Well, I have no bar underneath my inequality. So this one's going to be a dotted line. When I connect them. Okay. And what kind of shade do I need? Well, it's eating y, so this one's going to be shade above. So everything above that dotted line is going to get shaded. And now we're going to look for where they cross in color. So where are they crossing color? Well, they're crossing in color in this little kind of corner over here. Okay, only. So I'm only going to shade this part. So when you guys do your practice, you're going to have to bring out that crossing in color a little bit more, either with a highlighter or make it darker, because that's all the points where they solve, or they make that system of linear inequalities true. So any points over in the shaded area make that system true. All right. And we have our last one here. Okay. Again, I want to look at them, see if they're in slope-intercept form. So do they look like y equals mx plus b, where y is all alone on the left-hand side? Yeah, both of them are. So what I'm going to do is I'm going to take my first one, pull its slope out, pull its y-intercept out. So this one's slope is negative 3 over 1, because that's my m right now. And then my b is just regular old 1. Okay, so at 1, here's my y-intercept, and I need to go down 3, so it's going to fall from left to right. So down 1, 2, 3 to the right one. And I keep going. I could also start at the y-intercept and go up 3 to the left one. Then what kind of line do I need? Well, I need a solid line, because I have a solid line underneath my inequality up here. So to connect these with a solid line. And what kind of shade do I need? Well, it's eating y, so I'm going to shade above. So everything above that line gets shaded there. And now I'm going to look at that bottom one, that bottom linear inequality. So I got my slope and my y-intercept, since it's already in slope-intercept form. Well, its slope is also negative 3 over 1, because that's my m out front of my x. And my b is negative 2, because it's tacked on the end. So at negative 2, here's my y-intercept. I need to go down 3 to the right one for my slope. I could also go up 3 to the left one. Okay. And what kind of line do I need? Well, since I have a solid line underneath my inequality, this is a solid line when I connect them. It's a solid line. The best you can. There we go. It's rough, but it's good. Maybe I'll redo it. Let's see. That's better. All right, there we go. And then what kind of shade am I doing? Well, since it's eating negative 3x minus 2 up here, okay, I'm going to shade below that line. So everything below that line is to basically the left of it. And now I'm going to see where they cross in color. But if you look here, they're not even crossing in color. So what do you guys think? Well, since they're parallel lines, are they ever going to touch? No. Okay. And we said if they're parallel, then they're going to have no solution, which makes sense because they're not crossing in color. Okay. So it is possible to get no solution. And again, you could show me that by writing out no solution or doing the 0 with the line through it. That means the same exact thing. So the moral of this lesson is we're graphing two linear inequalities, okay, and are on the same graph, and we're shading where their solutions lie, which is where they cross in color, okay? So you guys need to do the 6.6 assignment and look at these notes as you're doing it. Shade. You might want to use any color pencils if you have them at home, and any highlighter. Bring that crossing in color out, okay?